The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody, and welcome to our first webinar in 2024. And appropriately, we're going to be talking about what's new in our upcoming release of the 2024 products. For those of you who don't know me, my name is Joe Anand, and I'm the product manager here at MecSoft. And today I'll be joined by Don LaCourse, our support manager, who's going to be actually doing the demos and also talking about these different features. So before we get started, a little bit of housekeeping. Next slide, please, Don. Yeah, you can use the chat window for questions during the webinar. We want to keep it as interactive as possible. And then if we have some time at the end, which I doubt very much, we'll have some questions, and I will reserve it for questions and answers. And the recording of this webinar will be made available in a couple of days after give us a chance to clean it up. And also, if we don't get a chance to answer your questions, we will have a record of your questions, and so we'll be sending out any answers to unanswered questions. And I'll be in the background listening to your questions as they come in, actually watching the chat windows, so we'll be monitoring it, and then we'll be responding, as soon as possible. So today's agenda, we're going to, as I mentioned, the preview of what's forthcoming in our 2024 product release. We're hoping to release in the next few weeks. And we have quite a few enhancements, as you can see in this list. This is just a sampling. There's other enhancements. And as always, we've fixed a lot of issues and a lot of usability annoyances, based on your input. And for those of you who know, it was known as for a while, we're always about constant improvement of our product. So we're always constantly improving it, making sure we're fixing bugs and things that that you find not very easy to use or things of that nature. So anyway, regarding the features we're going to be talking about, we're going to be starting out with usability enhancements. We're going to be talking about posting order changes that we have done. Save and load post enhancements that comes directly from a lot of customers' experience with our existing feature for loading and saving posts. Then we'll jump into the hole making enhancements, and we'll talk about 5-axis drilling there, a new method that has been introduced. And then 2.5-axis machining, we've introduced laser tools. For those of you who are doing laser machining, that was a constant request from a lot of you. We also added negative offsets in the face-off machining. And under 3-axis machining, quite a lot of work has been done there. High-speed machining for facing has been implemented. Actually, we had that version, but it's been completely rewritten, and it's much nicer now. Then also for the surface boundary computation, when you select surfaces for machining, part surface for machining, we've introduced a tool contact condition. That's actually a very nice enhancement for mold makers. And then we've also added an enhancement for exact Z-level distances. That was a problem for certain applications where people wanted to maintain exact Z-level distances between each successive Z-levels. 4-axis machining, we've introduced machining about the Z-axis. So if you had some sort of tombstone type of fixtures, and a 5-axis machine, now you can rotate about the Z-axis and machine, which is a nice enhancement. Also, again, using the secondary axis of the rotary axis if you have a 5-axis machine. And then a couple of small enhancements in 5-axis machining. We're recomputing angles without actually regenerating the entire toolpath operation list, which can be a big time saver. And then finally, a little bit about licensing. This is for network lock licenses that we've pushed out a lot of enhancements here. This is mostly for IT people and people who are running multiple licenses on their site. So without any further talk, I'll let Don jump in. Don, all yours.
Hello, everyone. Glad you could join us today for our first webinar of 2024. We're going to be reviewing the items that Joe just mentioned in the agenda in slide form. So we have a presentation that we're going to go over. And then after that, we will actually do a demo and show you some of these things in the product itself. So first up on the agenda is the usability enhancements. And a lot of users have asked for the ability to give tools certain priorities to post them out. Obviously, if you have an automatic tool changer and you got tools 1 through 5, filled in your tool changer, if you don't happen to have those that specific order in your machining job, now you can tell it to post them out based on the tool number. If you look over here on the left, you can post out based on how they appear or the order that they appear in the machining job, or you can post it out based on the priority of the tool, increasing tool number or decreasing tool number. And if you see over here on the far right, you'll see a sample post with that tool order enabled. And it basically just rearranges your post and posts each operation out based on the tool number, all of tool 1, all of tool 2, etc. And then also, while we're on this dialog, we also added the ability to save and load posts to a file and from a file. Users have been asking for this and sometimes getting confused because their posts get changed and I'm not sure why it's changing. And you can use these options here to make sure you always have the post that you intend to have in the files that you use. Okay, so let's go to hole making enhancements in 5-axis. This is pretty cool. You can, similar to 2-axis drilling operation, you can do this now in 5-axis. There's a little picture we see here. You see that we have points actually on the contoured surface, and those points are treated the same way in 2-axis or hole making, and the tool gets aligned normal to the 5-axis surface at that point. So you can define a standard tool the way you normally design your drilling, and it'll do it in 5-axis. So you can see the 5-axis motions here in red, and then the lead ins, and then the normal direction to the points. So I'll show you that. So the 3-axis, this option here allows you to skim across the in-process stock. So if you look at this picture on the right, you'll see that when the tool has to clear the part, it will retract to the fullest position on the clearance plane. When it just needs to move from one point to another on that level that it's cutting, it will obey a skim clearance. So this is a combination of clearance plane and skim clearance together and uses them optimally.
The change here in 2024 is before 2024, it only used the part geometry to compute the skim distance.
Right.
Now it actually uses the in-process stock, and then it'll clear the uncut material also.
Yeah.
This was an enhancement that people have requested, so that's why it's in the product now.
Yeah. And also it does it at every cut level, so it'll calculate that. If it needs to move from one point to another, it will use that skim clearance. Okay, so let's go on and see. We've got our 2-axis enhancements. Two things here. We've got face top operation on the left. You see the 2.5-axis face top cut parameters dialog. And now you can specify a negative cut area expansion. What this is, if you look at this picture on the right here, you'll see the tool path for the face top. In this particular example, we just have one tool path going across with our face mill. And typically, the tool would go out and make sure it passes the part completely. Now you can tell it to stop inward of the part by giving a negative cut area expansion over here. So it's just basically a way of moving it in on both sides. If you don't need the tool to go out that far, you can move it in using these parameters right here. Also, when I get into the demo, we're also going to show you the laser tool. We did a new laser tool definition. I'm going to cover that. It's not in the slide here, but I'll cover it in the demo. Now, also in 2.5 axis basing, we introduced high-speed cut connections. If you see right here in cyan, I guess that purple, light purple color right there. Typically, it would just be a straight corner. As if you look over here, there's a corner here, and that tool has to make a very sharp stop and then a sharp, turn to another direction. We've introduced high-speed arcs in the tool motion itself, so that that helps save your tools. Also, it's less rigorous on your router, and also cuts down on the machining time. So that's in 2.5 axis basing. Now, in here in 3 axis, a lot of users were a little confused about how the cut levels are calculated. The way we did it internally, you would think that it would be the exact distance, but the way it's done internally, based on the geometry itself and the depth of the total depth of the cut, internally it may calculate to a slightly different step down in different areas. Well, what we've done here is we've introduced a parameter that forces the step downs to be an exact distance. And that's more the way, more intuitive to how users are expecting the product to behave. So you can do it either way. You can check this box on or off. You do have to have the distance option checked with the distance specified in order to use this option, to use distance as specified, and we'll show you that.
Yeah, this enhancement was specifically done for products, for users who are using terrain models and things of that nature, where they're actually creating geometry on specific or equally spaced Z levels, and they wanted to machine on exactly those Z levels. So that's the reason we've added that.
Okay, this is one that I like a lot. Now in 3 axis, previously in 23, we had the 3 contact conditions on, to, and past. On the tip of the tool, when it aligned vertically with your control geometry profile, the tool would stop. The to condition, when the diameter of the tool touched any vertically lined up with any point on your profile, it would stop. And then the past condition, the diameter would go past the control geometry at, if you look at it vertically, the opposite side of the tool on the outside of the control geometry curve would stop. Now we've introduced a contact condition. So basically, if you look at this picture right here in the middle right here, you'll see that the tool, when it cuts this cavity, when the ball of the tool touches the control geometry curve, or the, call it the parting line of the cavity, the tool will stop. That's very, very important for maintaining an accurate and clean parting line. Previously, you had to do some additional modeling to get some surface to help that tool go past that parting line and cut a clean and exact parting line. Now you don't have to do that, and this works very well on a number of types of cavities, and we'll show you an example there. If you move over to the next column over here, just by doing a cut material simulation, you can get an idea of how your parting line can be sacrificed. If you're anywhere, if you're not anywhere, but if you have been designing or cutting molds for any length of time, you know that the parting line is the sacred cow. You cannot violate it. You can't let the tool roll over the parting line, because what can happen here is if you look on this bottom view, the tool actually, we used the on condition, okay? And the tool went right up to the center point, went right up to the curve, your control geometry. And what that results in is some overcutting on areas of the parting line itself. And this is just a blow up over here, you can see. And that will show up in your mold. If you're doing like a prototype mold, you'll see flash. This is a flash area right here. That's not good. So in the top picture right here, without having to do anything, you just set it to contact condition. The tool stops whenever it contacts that parting line curve, and you can see in the simulation how clean that curve becomes, or that parting line becomes. That's a very, very good advanced enhancement that we've added for tool and die makers or mold makers. Now in 4-axis, we've had users request the ability to be able to machine with the rotary axis being in the Z-axis, up and down, okay, and rotate around in that Z-axis. Now you can set your machine to 5-axis mode, and you can run 4-axis operations in the 5-axis mode using the Z-axis as your secondary 4th axis, your primary 4th axis. Set that to Z. Normally this wasn't available, and up until now, these were grayed out. So now you can use the Z-axis, both a positive and negative Z, for doing 4-axis cutting in 5-axis mode. Now this one here, sometimes in index 5-axis or 3+2 machining, where you have a lot of different angular faces that you need to machine, and that tool needs to get, obviously from one area normal to another area to another one, and there's a lot of motions in between that need to be done in order to get that tool over there. Well, now you can, based on the order of your operations, you don't have to regenerate all of your operations in order to get the optimum transfer angles from one plane to another. Now you can do that automatically without having to regenerate all these operations, because the 5-axis operations do take longer to generate. If you have a large complex model, it could take a while to generate to get those angles recalculated.
Well, the angles, the toolpath itself, this really comes into play when you're reordering toolpaths. Let's say you created toolpaths or machining operations in the in 5-axis mode, and then you reordered them. And now what happens is internally we compute the machine tool angles. You normally won't see it on the graphic screen. Everything will look correct, but the machine angles, or the machine tool angles, which is the primary and the secondary angles, will be out of sync because you reordered the machining operations. So that's this method, or this option that we've introduced, will recompute all the machine angles based on the current order of operations. Thanks, Don.
Sure. Okay. While you're talking, you want to cover this, Joe? The licensing?
Yeah, so this is a new UI we've introduced for the network lock licensing, which helps IT personnel to implement our network multi-user network lock licensing model. So we have additional information displayed, which can help the IT person figure out where the operations, where the actually executable exists, which was a big question that a lot of people had in the previous release. We've also added firewall rule creation utilities to allow standard firewalls to open up the channels for communications. And then we also had a registry file creation utility. This allows IT people to locate the license in the HKLM registry, and so that way the clients don't have any idea what license key is being used. This is for protection for licenses. And then also, saving the server settings in the registry. These are some of the user enhancements that have been added to network lock licenses.
Thanks, Joe. Okay, so I think we're into the demo right now, and I got some parts lined up to talk about. Our first item in our agenda was the usability enhancements, posting order and save load post enhancements. So let's go to, excuse me, let's go to this part right here. Now, looking at this part, you'll see that we have a number of toolpaths over here, and they're in different orders. In other words, when you program those, you may have had tool number 2 as the first operation for the rupping. And as you see in this post order here, we have T2, T4, T1, and T3. Well, before in version 2023, when you posted the setup, it posted it based on how they appear in the list. So the tool 2 would be used, then 4, then 1, and then 3. Well, now you can automatically reorder your post so that it uses the tool numbers in an ascending or descending fashion. If we go to the CAM preferences dialog and we go to machining, machining, that'll be user interface, I get under post processing. We got a couple of new sections down here. One's called post order, and you can just tell it to post in the created order. In other words, how they appear in the machining job tree. That's the standard normal the way it acts in version 23. Now we can do it also in ascending tool order, increasing tool order, or decreasing tool order. And I can go ahead and do a post and show you that. So let's go ahead and pick OK. Let's set it to increasing order, pick OK. So now I'm just going to post. Now you can still post obviously any operation you want, and you can send it to your machine in any order that you want. But if you want to post them all, you got the option now to sort these tools based on tool number. So we're going to go ahead and post that. So you see that this note up here lets you know that the tools are being sorted based on ascending or ASC, that means ascending order. And you'll see that now we have tool number 1 done first, and then down, when we do a search here, I guess we can do a search.
Yeah, if you can see in the machining job order, if you see the order of the operations, it's to T2 followed by T4 and then T1 and T3. That's the order that you have created the operations in. But in the posting, if you look at the order.
So we got T1, let's go find T2. Oh, sorry. T2 coming up next, and then T3. And again, this is just another way of posting, saving you time. You don't have to, when you're ready, when your project is done, typically you would review your machining job, making sure you've got, your tools in the right order, the way, if you want to use all of the operations with this certain tool number, you want to make sure that's all grouped in the same order in your machining job. Now it does it for you, basically. So that's T3. Let's go ahead and find T4 next in the list. T4 and then T5 at the end. Didn't find a T5. Let's
You don't have a T5. You don't have a T5.
Oh, okay. Okay. So that just saves you time, less, less worrying at the end. You got a lot of things to do. You want to hurry up and get this thing cut. So this is just some time-saving enhancements here. And you can do this. Go ahead, Joe. Was you going to say something?
No, go ahead. Finish up. I had a note about Rhino 8. So.
Okay. And you can do this based on increasing or decreasing tool order. That's all I was going to say, Joe. Go ahead.
Yeah, quick note, if you notice, we're running 2024 on Rhino 8. So that's also something I just wanted to point out. 2024 will run only on Rhino 8 and Rhino 7. Rhino 6 is not supported on 2024.
Okay. Okay, so let's go to 5-axis hole making. So we have a part here with a half sphere on the top, and we need to drill holes on these faces. Okay, so basically it works the same way as in regular hole making. In regular hole making, you see, let's go in here and just show the dialogue while we're doing that. So in regular hole making, the tool obviously is lined up in the Z-axis, and you're drilling a hole at a point or at an arc or at a circle. In 5-axis, it works exactly the same way. Your point is on your surface where you want to machine. You don't have to have a hole, just like in regular hole making. You don't need to have a hole. The minimum, all you need is a point to locate that drilling operation. So in 5-axis, it will align the tool normal to the surface at that point, and just drill your tool based on that. So let's just look at the cut parameters. Everything is basically the same in this dialog right here. The tool is lined up. Excuse those pop-ups. I forgot to turn them off. So the tool is lined up on your hole, and it does the same thing in the 5-axis. It aligns itself at the hole and cuts the tool depth. Everything in this dialog is virtually identical to regular hole making, so there's not going to be any confusion. Shouldn't be any confusion about how this works. The only thing different is that obviously you're locating on a 5-axis contoured surface, and the tool automatically aligns normal to the surface at that point. So everything else is the same on the drilling. If you got any questions, put them in the questions panel, and maybe we'll have some time at the end and we can cover them. If not, we'll get in touch with you separately.
Hey Don, can you show the toolpath and also run the simulation on this?
Sure. There's the toolpath, and let's go ahead and just run that. We have some tool collisions. Let's go pick yes. It's actually, yeah.
Let's turn off the stock model.
Turn off the stock. Better idea. Turn on the part. Okay, so let's back up a little bit. Okay, so there's our tool, and let's go ahead and slow this down and play. And we'll just get rid of that. So the tool, it goes back out to your clearance. It may be a cylinder, a sphere clearance, whatever your clearance is. It makes its approach and then aligns up normal to the hole. And then cuts the hole. Which is pretty cool. You see that the tool is already lined up normal to the surface during the approach. Let's speed that up just a little bit. So that's how it works. Pretty cool. Okay, so let's go over to negative offsets, and we're going to talk about the laser tool as well in this one. So let's do the laser offset, not laser offset, base offset. So that would be this, I believe it's this one. Okay. So normally, let's go into that's the normal condition. If you look here, cut parameters, these are 0 typically, and we had this option, but you could add distance to get the tool out, but you couldn't put a negative value in there to get the tool not to go out as far as it does. So we've introduced that. So this is, let's go to the front view here. See that a little bit better. So let's go ahead and just slow this down and turn that off, and we'll just play it pretty fast. But you see that the tool went way out on the end. Obviously, your diameter of the tool, the center of the tool doesn't really need to go that far past the edge of your part or the edge of the stock in order to face that off. So in this example over here, let's go to we go ahead and introduced a negative offset value where you can bring that tool back in either in the length direction or the width direction. And let's go ahead and just run that real quick. So it just brought it further in, so you don't have to waste machining time. Okay, so while we're in here, let's go ahead and go into the tools dialog. And if you look up here, just ignore the letters. This is a development, it's still in development, so not all the icons are done yet, but the icon on the end will be for laser tools. And you can tell it the width and the height or the cutting height of the laser and the width of the laser diameter itself. And you can specify that and enter a name, obviously, and just save that as a laser tool. And that can be used basically anywhere that you can use an end mill, I imagine. Anything you're going to profile on laser cutting, typically you're just profiling.
Yeah, it's typically only in profiling. You wouldn't use it in pocketing or anything like that, but we have a lot of options in the profiling itself that you can use, for instance, looping in the corners and things of that nature that you can use for laser machining. Another note that I would add is if you look on the right side of the dialog, we've added some parameters specific to lasers, for instance, pierce dwell time on the power. Which is these are all transferred to the post processor. So if you're using a laser operation, a profiling operation to drive a laser machine, you could use those in the post processor and set up the post processor accordingly. So,
and if you do have a if you're a new user and you do have a laser machine, just get in touch with us, and we'll make sure your post is set up the way it should be for your specific machine. Okay, so that's the laser tool, the new laser tool. Let's go ahead and go to 3-axis. Okay, let's do the contact conditions first, since that's my favorite. So basically, we just have a cavity mold insert block. We got a cavity. The parting line is out on this curve, around this curve. And if you go into the, we have a 3D offset pocketing operation toolpath. And if you look here, we have 2 surfaces selected on this half of the cavity. And we have the contact condition set to contact. Okay, and then let's go ahead and simulate that. So if you look at, I'm going to go in and make this stock not so. Let's make it more transparent. Okay. So basically what I was saying is that if we go into the front view and you'll see, let's turn the toolpath on. And then let's go here and just look at this toolpath. And let's turn the part. Let's just make it a wireframe, be a lot easier. So what I'm getting at here is that if you go down at the bottom, go up from the top, you'll see that the tool stops, the toolpath stops, or a little bit more than that. Okay. So when that tool touches that contact point on the parting line, it stops. And that's very, very important for mold makers to get a clean parting line. Typically without this in 23, the center line of the tool would line up with that point on the parting line, which would cause some overcutting on the outside of the parting line. And either one of those conditions, either the on, obviously the past would not be good either because the tool would go all the way past it. But even at the to condition, it would be an undercut of the cavity. You wouldn't go all the way to the parting line. And before this, if we go back into the isometric view, let's go back up here. So anyway, that's just a very good option for mold makers to get a real clean cut on that parting line. What I was going to say is before this, what we normally would do is untrim these surfaces, extend those surfaces out so the tool could just ride past the parting line. But that adds extra tool paths, that adds extra modeling time. If you don't have to do it now, you don't have to. It just stops right at the contact point. This part is made up of multiple levels from contour data, and a lot of users make contour maps, and obviously you'd want the tool to cut on each one of the layers. Well, prior to 24, the way it was calculated internally, you may not have the tool actually cut exactly on one or two or more of those layers. So now let's go to the front view. And we'll look at the operation itself. So if you see here, without let's go into the operation dialog, go to the cut levels. We have it set to a distance of 1, and we don't have the use distance as specified checked. You don't necessarily get a cut level at each one of those surfaces, okay? You would have to use a clear flats area in the horizontal roughing or horizontal finishing to force the tool down onto those layers. Now you can just tell it exactly in the check this box, say, I want to use exactly that distance. I don't want it to change throughout the entire cut. So let's just regenerate that. Any questions? So here you see that obviously it stopped exactly at 1 millimeter increments, which is the distance between these flat area surfaces in this terrain model. So it's just a better way to, to predict exactly, or not predict, but to control exactly where that tool is going to cut on the levels. Okay, so let's go ahead and let's see what else we got here. Let's look at the high-speed machining and facing. If you look at the facing operation here, let's go to this one. This is the normal way it's done in 23. You'll see all we have for geometry is this open curve here, and it calculates a facing tool path, and the tool comes out and about. Let's go ahead and just show that tool. Let's go ahead, turn that off, turn that on, and let's slow this down. It's even too slow. Let's go ahead and change this. That should slow it down a lot. Okay. Let's do a pause and restart that. So what I'm getting at here is that look at these corners right here, real sharp corners. So it's going to come out, stop, stop, jerk, you know, when it's going at each level. So now, let's pause that, stop that. Let's go ahead and do this one. And you'll see that with the high-speed cut patterning in the facing, it adds these arc motions going from one level or from one area on the toolpath to the next. Let's go ahead and play that.
It also adds arcs in the toolpath itself, so you can see the arc motions. There's some sharp corners you can see still, and we are working on that when we release this product. Even those sharp corners will be adding arcs at that point also. So.
And I believe, do you have to use the facing cut pattern? I mean,
yeah, we already have high speed in pocketing, and then this is just the addition to the facing.
No, I mean in the facing, the cut pattern options in facing, does it have to be the offset cut pattern, or can it be any?
No,
can it be linear?
There's a separate high speed option that's been it's always there.
Okay, so you got to use that in conjunction with the high speed cut pattern.
Yes.
That's what I was asking here. Let's go over to roughing. So we got a high speed cut pattern. Okay, so let's go on to 4-axis. If I missed anything, Joe, just let me know. 4-axis. So basically in 23, you couldn't do the 4-axis with the part aligned the way it is right now. You would have to roll it over to extend either in the X-axis or the Y-axis and perform the extra Y would be the rotary axis, and then you would only be able to machine it in that axis. Now,
well, there's Don, that's partially correct what you're saying. Well, there's one way you could have done it. You could have used setups and rotated the setup where the X and or the Y axis is pointing in the Z-axis.
Yeah.
But the problem with that, the transformations were being computed like you had a 5-axis machine. So we have actually fixed it, and you don't really need to use a setup. And then we had 4-axis users who did not have multiple setups in the configuration, so they wanted this option. So we introduced this option. Where you don't have to introduce a setup to machine along the Z-axis like this. So.
And if you want to see the machine, so in this case, the machine's set to 5-axis, but we're going to cut in 4-axis mode. And do you have to have that checkbox checked, Joe?
No. So what happened if you think about it? If you just had a 4-axis machine, the tool axis is actually pointing down straight down in Z. So if you had a rotary axis like this, and the tool is pointing straight down, you really can't machine, in 4-axis mode, because you got to be normal to the rotary axis in 4-axis mode.
Right.
So for the tool to be normal to the rotary axis in this particular case, you have to do a rotation of the tool about the secondary axis by 90 degrees to make it normal. So that's why you need to specify a 5-axis machine tool, but you don't need to specify the second, as the rotary axis, the secondary axis as the rotation axis. So internally what we do is we'll take care of creating the rotation about the secondary axis by 90 degrees. That'll bring the tool normal to the Z-axis, and you'll be able to machine.
Okay, and this works in 3+2 as well, right? Or do you have to have 4-axis? You got to have the expert plus. Do you have to have the 3+2 on top of that?
This is only for 4-axis continuous machining. Yes.
Okay. So any questions on that? Obviously, Joe would be able to handle those, and we can
one more while you're at this dialogue. The other option that we have added, the other function or option that we have added is if you have a 5-axis machine, you can use the secondary axis. If you look down at the secondary axis parameters, there's a new checkbox that's been added. Let's use the rotation axis. The secondary axis has the rotation axis. So we've had customers who had 5-axis machine tools who use 5-axis continuous toolpaths. But then when they go to 4-axis, and they also want to use our 4-axis continuous paths. So when they did that, the only option that they had available for them is to actually create a 4-axis machine tool, because we only rotated about the X and the Y. So now we allow those users who have 5-axis machine tools to actually rotate about the secondary axis of their 5-axis machine tool, which is actually a pretty nice feature, and use all for 4-axis methods. What this does is two things. So it allows the 5-axis users to use our 4-axis methods, and number two, we don't have to have two different post processors, one for 5-axis and one for 4-axis. So we've integrated that as well. So unified that with a single post processor. So hope that makes sense. If you're not a 5-axis user, it probably doesn't make a lot of sense, but if you are, I'm sure it'll make some sense at least. So.
Okay, thanks, so let's see what else we got here. Looks like we're going to have a little bit of time left over, Joe.
Don, please show the toolpath. And
yeah, obviously.
Simulation too. Just run the toolpath, yeah.
Let's go ahead and do it. So previously you could not do this, and the way we got it set up right now. And the axis right here, the Z-axis, is obviously is the rotary axis now. Normally you would have to flip that over, on the X or the Y, correct, Joe, and do that, have it set up that way.
Yes.
Okay. Okay, so let's see. We've got 5-axis recompute angles without a regen. Okay, so let's go and look at, doesn't look like I have that one. Let's go ahead. Let's see if I open it.
I think you might want to show this. Well, you don't have it in 3-axis also. I think we're pretty much done with all the features that we have. We are coming out. There's a couple of questions that have come in. So when is the product going to be released? Yeah, that's a very standard question we get all the time. So we are hoping in the next couple of weeks we will release the product, and at the latest it will be end of this month, but end of February. But we're really hoping to get this done in 2 weeks. It's looking pretty stable, and we are running our testing and making sure all the different pieces of the product are still working correctly. And once we're satisfied with the quality, we'll release it. So earliest is 2 weeks, and then latest would be about 4 weeks. So.
Okay, I just had this part up for recomputing the angles in 5-axis. Here is it. We have.
Yeah, you can't really show that.
Yeah, but I'm just wanting an example.
Okay,
you could just right click and recompute. Let's see, that would be from the setup. You got to do it each setup level. Recalculate angles. So you can do that without having to regenerate. In order to verify your angular moves from one operation to another. Is there any other questions, Joe?
Yeah, there's one other question. Are these upgrades free of cost for the 2024? Yeah, if you're on AMS, and I think most of the people here are on AMS, or our annual maintenance service subscription, then the 2024 upgrade would be free of cost. But if you're not, and there will be an upgrade cost to go from your previous releases, whatever release you're on, to go to 2024.
And also, just wanted to mention too, as far as the maintenance, there's a lot of other benefits you get from the maintenance other than just getting the upgrades. You get our CAM Jam self-training videos and guide. You get all kinds of printed materials as far as exercise guides and all kinds of different guides that you get. And you don't get all of that if you're not on maintenance. So it's good to maintain your maintenance. Okay, is that about it, Joe?
There's a couple other questions. There's a question on exact cut levels. How does it handle the bottom cut level if the total depth of cut is not multiple of specified cut levels? Okay, that's a good question, actually. So the reason we never used the exact distance, I wouldn't say never, but the reason sometimes the exact distances were not used was because taking the entire cut depth into consideration, we wanted to output an integral number of cuts. So there's a cut at the bottom level as well as a cut at the top level. So sometimes that would be in conflict with the distances specified, right? Obviously, because if it doesn't divide evenly or come up with an integral number, then you would have some cuts in the bottom or at the top that are not at the exact bottom level or at the exact top level. So this is the reason why we actually changed the Z level distances to reduce it actually slightly to give us the integral cut numbers. So we would have cuts at the bottom level. Okay. But so now with this distance, if you specify exact cut levels, what will happen in those situations? In those situations, yeah, you're not going to get a cut level at the bottom. So it'll just be left out.
So you'd have to enable the clear flats in order to get one at the bottom if it's a flat?
Well, yeah. I mean, usually you would use the other option. You would just uncheck this option, and it'll use the 2023 default behavior. Mm-hmm. And if that was working for you, then just continue using it. Do not use this option. The only reason you would use this option is when you want it exactly, like in a model like this, where they have terrain models with equally spaced 1 millimeters between each of those terrain levels. In those cases, yeah, you are going to get one at the bottom because everything's equally spaced.
Okay. So. Okay.
One more question: is my older post processors going to work with 2024? Yes, absolutely. They will continue working. The only thing you have to be aware of when you upgrade would be to move those older post processors. If we have done any customizing on those old processors, old posts for you, you got to make sure that you're still, pointing to those old post processors. And it's a very simple way of doing it. When you upgrade the product, there's a little checkbox in the installer that says, do you want me to use the existing options of the previous upgrade or the previous version? And if you just check it, it'll just use the old post processors. The other way is to actually manually copy those posts over to the new post folder.
Yeah, a lot of users they miss that checkbox at the end. They just go through the install, because typically on applications they probably don't ask you a question, do you want this or want that? So just make sure that you check that when it asks you during the installation, and you'll get your preferences. Okay.
Okay, that's about it. Looks like a little bit ahead of time. No more questions here, Don. Yep. So again, thank you all for attending, and hope to see you in other webinars during the year.
Yep. Thanks, guys. Y'all take care.
Bye-bye.
Bye.